Okay, good morning, ladies and gentlemen, and welcome again. Thank you for spending your Saturday morning with us. I just noted the discussion earlier about how many schools and how many people. It's not the number that counts. I shouldn't be saying this, I'm a maths person. But it's about the level of commitment, even if it is a few of you that have made the journey up to UCT to be with us. We appreciate it. Okay, so I'm going to use everybody's been picking on Sunette and how long she's been here. She's been here for 5 minutes, and I've been here for 5 months. So I've also just arrived, and this is a new field for me. Where have I come from? I've spent the last 24 years lecturing mathematics at the NMMU in Port Elizabeth. Yay! Oh. Oh, of course I know. Computer science. Okay. So, yes. And I have lectured mathematics to engineers, to commerce students, to teachers. I have a huge experience in terms of mathematics, teaching and learning. And my passion lies in teaching mathematics. Very much like yours. How many mathematicians are there in the room today? Oh, just one. Okay. So I hope the rest of you are going to appreciate some of the maths problems that I put up. Okay. Okay, so it's my task today. I'm pressing the wrong button. My task today then would be to demystify this domain of mathematics. And I think that all my colleagues before me would attest to the fact that it's not an easy task to demystify this subject. Okay, so it is known as the math test, and its content, as I've said earlier, is embedded in the NSC curriculum. So all of the items test on exactly the NSC content. The point of departure, I think, comes with the NSC is a school exit exam, and as such, tests whether learners have met the outcomes of 12 years of a mathematics curriculum, whereas the NBT is a university entrance exam, so to speak, and tests whether learners or writers are ready to face the demands of a higher education curriculum in mathematics. So that is the difference between the two. So the NBT doesn't necessarily test all of the mathematics, but will then focus on what is necessary for higher education mathematics, if that makes any sense. Okay, so the NSC, we know, so therefore, the NSC and the NBT are complementary, because we assume that having gone through an NSC curriculum, the learner already has all the skills in place. But the NBT then tests the depth of their understanding. Okay? What is expected of writers in the NBT context? We expect writers to read and assimilate questions. As I've said, that these concepts, the questions are embedded in the mathematical concepts within the NSC curriculum. We would like them to respond to information that is presented verbally, graphically, and symbolically, and we particularly emphasize whether writers can move between the different forms of mathematics. So, for example, to be able to look at a parabola, and just the gentleman in front will be able to appreciate that. I'm sure a lot of you remember your school mathematics, and be able to say, in terms of a formula or a function, that would refer to be able to be translated to a quadratic function. Very much in the equation-wise, it would be y is equal to ax squared plus bx plus c. So can you see the different forms and how writers are expected to translate? to be able to activate knowledge across different mathematical competence areas. So one particular item might not necessarily deal with a particular competence area. Very neatly packaged in, for example, geometry, however, in the NSC. But in the NBT, writers could be asked to answer an item that is perhaps requires geometric skills, trigonometric skills, as well as algebraic skills, okay, all rolled into one. And then they would have to reflect on their decision-making and problem-solving in terms of all the theory that they've already have at their disposal through going through the NSC mathematics curriculum. I'm sure many of you know that this test is a 3-hour test, and it has 60 multiple-choice questions. There are 4 options to each of the questions, and one of them is correct. The items of the test are set in such a manner that does not necessitate the use of a calculator. And one can also argue that because they don't use calculators, we are testing even further some kind of foundational understanding of the concepts rather than just simply plugging away at the calculator. A formula sheet, not unlike the one presented at the end of an NSC mathematics exam, is also presented with this particular test. And as Natalie has said, misconceptions are tested, but not all questions refer to the misconceptions. There is a progressive distribution along the cognitive level, so starting off with a very basic cognitive level just to get the confidence of the writers, and then moving progressively towards higher cognitive levels. And then all aspects of a specification table are represented. So the test is set up with a specification table in mind, and I'm not sure whether your handout will have some of the concepts that are tested in that specification table. And we do not have any queuing. So what do we mean by that? The items don't cue the writer to a particular way of solving this problem. The writer will have to bring along all their skills and to be able to negotiate a particular item and then decide what is the most appropriate way of solving this particular item. In the NSC, and this is not a criticism, but a typical NSC question could refer to a theorem, stating a theorem that says equal chords subtend equal angles. Hence, present them with a diagram, and there's that word again, Sanette, hence. Writers are presented with a diagram, and then they would have to use that particular theorem to find an angle. So that's the queuing aspect, which is not present in the NBT context. Okay, so the test comprises items which are distributed over 6 competence areas, and I will be sharing with you one of them soon. They're further subdivided into different subdomains, and they are categorized according to the cognitive levels that I spoke about earlier. Okay, so here's one of the, giving you an idea of one of the competence areas, because I'm going to be using this. This competence area is called algebraic processes. It is a very important competence area, especially for anybody wanting to do first-year mathematics. In many of the programs, engineering, computer science, they would be called on to do these kinds of operations in terms of first-year mathematics. So as you can see, A1, the competence area, algebraic processes, is further subdivided, and we test things like patterns, sequences, series, all things not uncommon to the NSC curriculum. Okay, and then going all the way to the bottom, A8, applying a given definition, determining the validity of a given assertion. Okay, the framework for cognitive levels, level 1 will just test knowledge and recall and simple routine procedures. Level 2, more complex but still routine procedures. And level 3 will be more complex procedures, choosing a particular strategy and solving across many competence areas, as I suggested earlier. Level 4 then is problem solving, working across competence areas where greater insight is then required. Right, let's look at what I want us to do now is to look at an example, and I'm going to show you how the NBT, and this example, by the way, is not on an NBT test. So I've just contrived it. And just to show you that this is what an example would look like in an NBT exam, and maybe you can tell me how it would differ in an NEC context, and then to give you an idea of how the kinds of thought processes and problem solving that this would entail. I'm trying to figure out, and this feels a little bit nostalgic because I haven't been in the classroom for a year, but I've forgotten where the button is to pointer. Is it just this one here? Oh, there we go. Right. So in this example, we're asking the writer for any real number x, which one of the following statement is always true. And Sunette and I had a conversation yesterday about, although this is the mathematics domain, in the language and how they interpret the language is very important, even in this context. So one can argue that in order to be competent, even with mathematics, one first needs to develop some kind of competence with regards to academic literacy as well as quantitative literacy. Okay, for example, the word always suggests that for every single value x, the statement has to be true. So there are no exceptions, okay? And for those of you who remember, a real number is a specific kind of number. It is a number that consists of rational numbers as well as irrational numbers, okay? So one then needs to understand what a real number is before one can negotiate this type of question. In order to negotiate further, you'd want to have to understand what a rational number is. A rational number can be written in the form a over b, where both a and b are integers, and b is not equal to 0, because division by 0 is not defined in mathematics. And then, as you can see, I am peeling away the levels of understanding just by the word or the phrase real numbers. Okay, so is that giving you an indication of how deep this is going? So if we look at the first one, this is the mathematician in the room. Mathematics educator should be able to tell me that this is a very common misunderstanding, because as soon as students see the negative, is negative x less than 0? Students are going to opt for that answer. Yay, it is a negative. What they don't seem to understand that within the x and living inside the x itself could very well be a negative number, because real numbers are both negative and positive. Okay? So that is clearly not true. So negative x is less than 0 is clearly not true. Okay? And then going on, is 1 over x rational? One needs to see, is there any counterexample that you can come up with that makes this not true? So if I come up with an example, x, that I can disprove this theorem, this theory, or this statement. How about 0? X is equal to 0 is a real number, and 1 over 0 is undefined. Clearly not rational. So once again, not true. Okay? And then here again, come up with a counterexample. If I let x equal to a specific number, any guesses? How about negative 1? I'm going to get 0 again. And negative 1 is clearly a real number. And then this side becomes undefined, and undefined is less than 1 doesn't make any sense. It's not mathematical sense. Okay, so clearly this one is the answer. And in an NSC exam, a similar line of questioning would simply say, solve this inequality. So although this is a multiple choice question, can you see the level of understanding that it would test and the number of concepts all rolled into one that it assesses? Okay, looking from the other point of view, how does the NBT results help higher education to align student competence to particular course requirements? That is where the power of the results lie. If we look at one particular area, and that is the algebraic processes, we can see that it's almost an inverse between proficient. Can you see that they're almost inverted? With the greatest number or percentage correct, and here the least number correct. Okay, very nice. If you draw that, it comes all the way down here in a negative slope, and if you draw a line from here to there, also gradually. So what does this tell us? It tells us about the profile. It tells us about the profile of our students in our first-year mathematics courses in higher education. It tells us how they're performing in a very vital subdomain, algebraic processes, and it empowers the first-year lecturer to take this information and to act in terms of relevant and meaningful support to these students. Okay? They're there, and we can't ignore that, and we need to address it. Okay, pretending it doesn't exist doesn't help. Okay, so we need to help these students to success. And let's take another level, going a little bit deeper. As a lecturer, I'd want to look at all the items that make up this first subdomain. Remember, there are many subdomains. I'm just looking at one. So there's all the items on the horizontal axis and how the students performed. And if you look at the basic category, there they are down there, as we imagine they would be. And here's the proficient writers up there. But notice here, something strange is going on. Everybody seems to have taken a dive. And as a lecturer of a first-year module, I'd want to know why. So it's almost like using it for diagnostic purposes. And I think that that is also helpful, something that you might want to do in your classes as well, in terms of diagnosing where the problem actually lies. Okay, and when I look at it, I'm looking at that particular, remember it's question 41, that there's this strange occurrence is taking place. So I want to look further into it. So I peel off another layer and I look at this item 41. What are they doing? And the correct key is A. And yet if you look at it, what is happening? The majority of them are choosing B. So there's clearly a misconception at play here that I would like to find out so that I can incorporate it into my teaching, into my curriculum. So there's the answers, and if you look at it, this particular question involves manipulation of surds, and they're clearly getting it wrong. So what they're saying is that the square root of 48 minus the square root of 12 is equal to the square root of 48 minus 12. Which is an oversimplification, and it's not true. So that is where they're arriving at their incorrect B response, whereas this is how it should have been done. So the square root of 48 is simply the square root of 4 times 12. But I know what the square root of 4 is. It's 2. So the square root of 48 is 2 square root 12 minus square root 12, which this gives me 2 of a kind minus 1 of it will give me 1. Of it. All squared is 12, and that is the correct. So I as a lecturer, am empowered now. I know what this problem is. So when I walk in to teach a particular concept based on certs, I cannot take it for granted that the people sitting across me know what I'm talking about. So I need to do a little bit of a support part, or maybe give a little exercise or pre-reading or pre-exercise in terms of what this is before I teach that first year concept, or first year concept that hinges on this. Okay, so just giving you one kind of example. So the common misunderstanding here was an oversimplification of the radical, whereas it should have been add first, because it's in a bracket. You've got to add what's under the square root first, and then take the square root of the single term. Okay? So there are many common misunderstandings, and I'm not going to go over many of it. I just want to show you the relevance to mathematics in specific contexts. Okay, and this would be in a physics class. If they were doing electricity and circuits, I don't know if any of you have done physics, and there are two resistors that are in parallel, and we want to find out what is the composite resistance or total resistance of that particular circuit. So we know that if it is in parallel, it would follow this particular formula: 1 over R total is equal to 1 over R1 plus 1 over R2. And then because the R1 has 8 ohm resistor, so it's 1 over 8 plus 1 over X, and this is the answer. But notice, this is 1 over R total is equal to that. So to get R total, I would have to invert that, which then means I have to invert that. Okay, so that is, if a writer or a particular student is having a problem with algebraic manipulation, can you see how that would show up in a physics class? So we call mathematics the queen of the sciences. Okay, and it's a phrase we take very seriously, because you can't execute the sciences without knowing mathematics. It forms the backbone. And then if you look at a physics class, again, if you're talking about vectors, here's the use of trigonometry. And if you're wanting to determine the x and y components of that particular vector, you will have to use cos 30 degrees is Rx. I haven't put the Rx on here, but the vector is this particular line here, and that's the Rx. So in order to find it, I would have to use that 30-degree and trigonometric ratios in order to address that. Okay. And then this is an interesting one. I'm sure that even if you haven't done any mathematics, you're going to find this interesting. Am I allowed to sneeze while I'm driving? During a hard sneeze, your eyes shut for 0.5 seconds. If you're driving a car at 90 kilometers per hour, how far does it move during that time? I think it's of relevance to everybody, and so I'm going to show you whether you're allowed to sneeze while you are driving. Okay, so if a car, and this is very much a combination of QL as well, because ratio and proportion is a QL concept within a mathematics concept, and one doesn't necessarily have to teach it in terms of a formula, because this could be a speed, distance, time formula, but we want to stay away from the formula and go into some kind of interpretation of the mathematics so that everybody can do it. Okay, so if a car moves 90 kilometers per hour, it moves 90 kilometers in 60 minutes, right? It moves 90,000 meters in 3,600 seconds. Agree? Everybody does that conversion, because there are 3,600 seconds in 1 hour, and there are 90,000 meters in 90 kilometers. So let's see what happens. So if we have 90,000 meters in 3,600 seconds, what do we have? What distance are we moving in 0.5 seconds? You're going to be surprised. 12.5 meters. Isn't that frightening? So the moral of the story is do not sneeze while you are driving. Okay, so yeah, so and there, if you were doing a chemistry class, anybody for chemistry, there's the use of the logarithmic function in chemistry when you find the hydrogen ion concentration for battery acid with a pH of 1, and there is the formula for pH. Okay, so putting that in, and this would then mean that I would have to manipulate that log function, which if it doesn't appear with a base, we can take for granted that it has base 10. Okay, and so this is the exponential of that logarithmic expression. Okay, and yeah. So I'm going to end with possible teaching and learning directions. Emphasize meaning in practical, graphical, and numerical terms. So if you're dealing with a concept, talk about it in all those different ways. Encourage learners to actually negotiate the concept and make it their own. Because very often I find that learners believe that the concepts are out there and in a book that belong to somebody else. They need to make it their own to understand it and to believe that it is theirs. Okay? Less emphasis in the plug and chug. So leave the formulas and don't say this is the formula we automatically go to when we have to solve this kind of problem. Encourage them to look beyond a formula and say, are there any other kinds of ways we can solve this particular problem? Can we perhaps draw a graph? Can we do a table? How else can we interpret this? And then maybe bring in the formula at the end to say, you've done all of that, we've seen it in different forms, here's the formula. And then encourage reading, questioning, and thinking about ideas and concepts in mathematics. Often as mathematics teachers, we are also feel a bit intimidated by questions. Don't feel afraid to say, that is a really good question. I'm going to read up on it and get back to you tomorrow. Okay, so even as a teacher, you can say, I don't understand everything. Mathematics is a very, very huge field. It's not possible for a person to know everything. Okay? Encourage looking at more than one approach to solving. You can look at graphical, numerical. You can even bring the computer into this equation and say, let's look at programs that help us solve these problems, so that when learners learn in different ways. Some learn visually and some learn verbally, and in all different ways. So you somehow can get everybody involved. Describe a function that you're talking about graphically, numerically, algebraically, verbally. Let's talk about it. And often students will say that problem and this, but they don't speak the actual language of mathematics. You have to force your learners to say what they mean. What is the domain of that particular function? You let them use the terminology of the subject. Encourage discussion and speaking of mathematics. It is a language. And then I'm going to end with a quotation by the mathematician Newman, who said, if people do not believe that mathematics is simple, it is only because they do not realize how complicated life is. Thank you.